The coastal ocean biome. Vast and expansive areas that cover the globe that when combined with other factors can become one of the most powerful forces on Earth. Human interactions with the environment and global warming are making this particular biome a force to be reckoned with. So what is the big problem and what can be done to solve it?
So what is the coastal ocean biome? It's a section between deep ocean and flat land, seen such as a beach. So most of the fish come from there and where the coral reefs grow and where we swim and play. In fact, while oceans cover 71% of Earth, only 7% is coastal ocean biomes. So the small strip of land is affected adversely by humans in many different ways: overfishing, industrial pollution, and agricultural runoff.
Because of the amount of coastal ocean biomes on Earth, literally every country touching any body of water are so high, it is pretty much impossible to give it a direct estimate on the temperatures of coastal ocean biomes. But I can say that coastal ocean biome temperatures range from negative 30 degrees all the way to 120 degrees Fahrenheit. The farther the equator the coastal ocean biome is, the colder it becomes.
Because of how many coastal ocean biomes there are on Earth, the rainfall varies in world location. The average elevation for a coastal ocean biome happens to be 18 feet.
In the biome, there are many different kinds of animals and plants, including things such as crabs, reef sharks, jellyfish, turtle, lobster, eels, sardines, sea lions, coral reef, algae, kelp, eelgrass, coastal sandalwood, caperbush, bracket fern, Douglas iris, surfgrass, and anything that you can find on the beach and in shallow water.
Now, I'd like to mention two important biogeochemical cycles: the water cycle and the carbon cycle.
The water cycle is important for coastal ocean biome because without it, no water would be evaporated from the ocean to rain on parts of the earth that depend on plant growth. Water is evaporated while on land and on the sea, rises condensing into clouds, and then eventually becomes heavy enough to rain, restarting the process by raining on land and sea.
The water cycle also controls the ecological function of aquatic life and increases the levels of dissolved oxygen, thus proving to be an important part of the coastal ocean biome.
So now on to the carbon cycle. The carbon cycle is especially important in our biome because carbon is the most abundant element in the universe. And alongside with oxygen, nitrogen, and hydrogen, it makes up many complex molecules. So carbon forms under the ground like this and stays there until it is drilled and used as fossil fuels. Once those fossil fuels are burned, the smoke of the fossil fuels enters the sky. This is incredibly vital for the coastal ocean biome because carbon is the foundations of life for life within the ocean. Without carbon, producers could not transform carbon into oxygen. And without producers, nothing could live in the ocean because they are the foundation of every single ecosystem.
Now that I've talked about coastal ocean biome and all elements important with it, I'd like to go into the issue: sea level rise.
What about it?
Well, the issue of sea level rise is actually quite controversial. Many scientists believe it's just the Earth going through a period that will soon return to normal, just as the Ice Age.
However, most are confident in the fact that global warming and sea level rise are impacting the world as we know. In 2014, global sea level rise was 2.3 inches above the 1993 average, the highest annual average in satellite history. And according to the National Ocean Service, sea level continues to rise at around 1/8 of an inch per year.
So what is the problem exactly?
Sea level rise has been thought to have been caused by the overmelting of snow and ice caused by global warming. Global warming is caused by the overusing of fossil fuels into the atmosphere, causing the destruction of the ozone layer.
As it is known, the invisible shield that surrounds the Earth, known as the ozone layer, is responsible for stopping harmful UV rays from hitting the Earth. However, in recent times, it's been getting more attention because in places across the world, including Uruguay, they have claimed to be a depletion of the ozone layer, and that can cause significant damage. This hole in the ozone layer causes the UV rays to melt snow and ice much faster than usual. And this can contribute to sea level rise because as the ice and snow melt, more water is being put into the ocean, thus the sea level is rising significantly.
So why is this exactly a problem for the coastal ocean biome?
If this continues, countries would be wiped out in less than a century.
In some places, such as Hawaii, many who have beach houses are being threatened by the predicted sea level rise and are having trouble selling their homes. If predictions are correct over the next 100 years, much of the world will have been submerged in the ocean. We look at places like the Maldives where this is already occurring.
So as for the biome itself, coastal ocean biomes are extremely sensitive to sea level rise. Most coastal ocean biomes will be able to accommodate around a 3 mm increase in sea level rise per year, as the maximum rate of reef growth is around twice this. However, as the rate of sea level rise increases, the depths at which coral reefs are able to survive may change, as will the shape and existence of some cays and islands.
At local scales, sea level rise is likely to increase sedimentary processes that potentially interfere with photosynthesis, feeding, recruitment, and other physiological reef processes. For example, it can cause increased sedimentation due to shoreline erosion, which can smother reefs and reduce sunlight needed for photosynthesis. Sea level rise can also inundate and erode coastal ocean habitats, such as mangroves and turtle nesting beaches. Mangroves may be able to adapt if sea level rise occurs slowly enough, if adequate expansion space exists, and if sufficient sediment exists to continue to accrete vertically to compensate for sea level rise.
High temperatures mean there's more evaporations from the land and sea into the atmosphere. It can be a direct cause of intense rainstorms. Intense rainstorms lead to more flooding. This paired with temperature rise can cause extreme drought.
So as you can see, sea level rise is not only an increasingly significant problem for mankind, but it is also one for coastal ocean biomes and their inhabitants. But what is being addressed to solve this issue?
Given humanity's current path, it is inevitable to prevent sea level rise unless we change what we are doing now. Global warming is largely influenced by human activity, and to change that would take a lot of effort. If we're looking at realistic or ideal solutions, getting the majority of the population to change their daily habits is not an option.
Our research concluded that a reliable solution can be building seawalls to prevent water from passing into coastal areas. However, as sea level rise is not so much of a current problem, we cannot be sure as to what the best solution is for what's to come.
So, what can an individual do to help solve this problem?
There are many things that individuals can do to help. One can simply write articles to inform others of the issue. Another idea would be to donate money to companies trying to solve this issue. It is so important that the everyday citizen is aware of such problems because it is they who make the difference to help aid sea level rise. Having multiple viewpoints on the solution may help provoke new ideas that can develop already existing solutions. The fight against global warming and sea level rise, it must be a group effort because this will affect everybody if it is not stopped or prevented in the coming future. How can science be applied to solve this problem?
Well, actually, there isn't much science behind the creation of seawalls. It is mostly geoengineering. However, science can help prevent sea level rise in other ways. Due to the fact sea level rise is directly related to global warming, if we wish to prevent it, we must go to the root of the problem, CO2 emissions.
One of the first ways science can be applied is by aiding atmospheric sunscreen. Volcanic eruptions that release massive amounts of sulfur, SO2, into the atmosphere provide a natural cooling effect because CO2 eventually turns into highly reflective solar particles that bounce solar radiation back into space. One proposal to mimic this effect would be to increase the planet's reflectivity by putting tiny particles of silicon dioxide, basically like kitty litter, into the stratosphere.
Other proposals to reduce the solar radiation reaching Earth include putting a large mirror or shade into orbit between the Sun and the Earth, or placing trillions of small transparent sheets in orbit to reduce the sunlight reaching the Earth's surface by 2%, sufficient to the offset warming even with the doubling of CO2, or laying a reflective film over much of the planet's deserts.
And finally, science can be applied to the idea of ocean absorption, whereby iron is added to the upper layer of the ocean and acts as a fertilizer, increasing the growth of phytoplankton, which, like all plants, creates carbon compounds by removing CO2 from the atmosphere. The resulting algal blooms, when they sink, would take carbon to the seafloor, essentially storing it away.
These are all great ideas for our viewers to consider, but the majority of the rest of the video will be focusing on actual current solutions, and in this case, seawalls.
By this point in time, we have talked about what a coastal ocean biome is, what it looks like, and what's within it.
We have also discussed how science is being used to address the problem with our biome, and how solutions such as seawalls could be a reliable option to combat sea level rise.
So now we're going to elaborate on the effectivity of putting seawalls just along coastlines like this. So how effective are seawalls in preventing sea level rise?
Now don't get me wrong, the construction of seawalls along the coastal ocean biomes is definitely an effective way to combat sea level rising for the moment. This may be able to work for the next couple of decades and maybe centuries. However, with sea levels expected to rise by more than 6 feet by the end of the century and almost 15 meters by 2500, the idea of seawalls will soon be deemed ineffective.
Of course, one of the biggest threats that rising sea levels stimulate is coastal flooding and erosion. A well-maintained and appropriately designed seawall will fix the boundary between the sea and land to ensure no further erosion will occur. This is beneficial for the shoreline, which is home to important infrastructure or other buildings of importance.
While time is definitely an issue in regards to the effectivity of seawalls, despite fixing the boundary between land and sea, seawalls also provide coastal flood protection against extreme water levels. Provided they are appropriately designed to withstand the additional forces, seawalls will provide protection against water levels up to the seawall design height. This makes them important and efficient at what they do, and is yet another reason why they are very effective at stopping sea level rising.
Okay, so what are we thinking cost-wise? Nowadays, money is immensely important when building infrastructures. So the effectivity of the seawalls is definitely going to be affected by the cost.
Well, you're right. One of the most significant downsides to seawalls is their extremely high cost to build. Seawalls typically cost between 5,000 and 10,000 pounds per linear meter. Thus, for areas like the 9-kilometer bay of Pennsylvania Bay, sea defenses like a seawall would easily cost around 75 million pounds.
Not many regions or countries can afford this expense, and certainly wouldn't invest in something that expensive without a guarantee that it could withstand the height of the sea that is expected within the coming centuries. 75 million pounds is only for a 9-kilometer coastline, while places like New York have a coastline length of around 204 kilometers. While it is obvious not all of the coastline would need to be protected, the price will still be around 1.7 billion pounds, which is not available for such actions as of this point in time.
Now, while there is a significant downside to the cost of seawalls, it could be said there is also a potential of an upside as well.
Yes, the increased security provided by the seawall construction also maintains hinterland values and may promote investment and development of the area. Although this does not make up for the huge cost of the seawall, it certainly helps.
Another bonus to the usage of seawalls is that if appropriately designed, seawalls have a high amenity value. In many countries, seawalls incorporate promenades, which are like long walkways along the top of them, which encourage recreation and tourism.
One of the most significant points to consider is the fact that while seawalls are so expensive, they could potentially be cheaper than rising waters themselves. If actions are not taken now, the annual cost of damage stands to reach hundreds of billions of dollars, at best as high as 100 trillion under grimmer circumstances.
Many papers also say that rising sea levels could result in nearly 5% of the world's populations facing yearly floods that drain almost 10% from the globe's economy.
So a part of these ideas, let's talk about the actual design of the seawall. But is it really that effective at stopping sea level rise?
Smooth vertical seawalls, which is how most seawalls are built to be, are at least effective at dissipating wave energy. Instead, the structures reflect wave energy seawards. Reflection creates turbulence, capable of suspending sediments, thus making them more susceptible to erosion.
In a worst-case scenario, reflected energy can interact with incoming waves to set up a standing wave which causes intense scouring of the shoreline. This outcome definitely poses a threat to future tourism for countries along the coastline, as without a beach, tourism levels exponentially drop. This is another reason why they are not effective.
But what about the environment? Taking a closer look at the implications of the science, we can see that building such huge walls would not only affect the world economy, but also the environment.
Well, until now, the environmental impacts of seawalls and other engineering have been inadequately studied. Research shows that these seawalls could have devastating effects on soft sediment ecosystems. It has been found that shoreline armoring negatively affects nutrient cycling, connectivity, productivity, and trophic structure.
It is common knowledge that the effectivity of a seawall is dependent on its ability to keep water out of the areas behind it. What is also common knowledge is that ecosystems need water to survive.
So while this may not drastically affect soft sediment ecosystems like mangroves, salt marshes, and tidal creeks due to the fact they are low energy environments, it will definitely negatively impact environments such as harbors, river mouths, and estuaries.
Now, one thing I do know is that the size and shape of these human-made structures often result in the loss of intertidal habitats, which are dynamic, high-stress areas that provide an important link between marine and terrestrial systems. So without areas such as these, the link between marine and terrestrial systems would be severed.
Oof, that's a big hit.
Yeah, so maybe seawalls aren't the most effective things in preventing sea level rise.
Well, to be honest, there's not much that can really prevent sea level rise. We can only really delay it until we have come up with a sufficient solution to take its place.
So these seawalls are more of a temporary idea rather than a permanent one?
Exactly, Sanchez. So now you, the viewer, have become informed on one of the most important problems in the world, and you can understand what is being done to solve it. You've learned about coastal ocean biomes and why they are important to protect. Now it is up to you to judge for yourself whether the science that is being used is really that effective, and whether such ideas, such as seawalls, should be immediately implemented across the globe, or whether we should think of something else. But time is ticking, so think quick. However, as the rate of sea level rise changes, most reefs... What are you doing? What are you doing? What are you doing? What are you doing? And then
We have also discussed how science is being used to address the problem with our biome.
As it is known, the ozone layer blocks harmful UV rays from impacting with the Earth. What are you doing? What are you doing?